Welcome to today's video on atomic structure and isotopes. Matter is made up of just over 100 different types of substances called elements, and these are listed in the periodic table as shown here. Elements cannot be broken down into anything simpler. Each type of element has the same number of protons. For example, let's take a look at this atom. This atom is of carbon 12. Carbon is the 6th element in the periodic table. So we would find that if we read along the periodic table, this is the 1st, 2nd, 3rd, 4th, 5th, 6th. So when we look at the periodic table, this would be carbon here. So the 6th element in the periodic table has in it 6 protons, as we can see there. So that is how I can tell this element here is carbon. So the 6th element in the periodic table, which is carbon, contains 6 protons. Another example might be the 54th element in the periodic table, xenon. Each atom of xenon will contain 54 protons. It is the number of protons that define what type of element it is. So all carbon atoms have 6 protons and all xenon atoms have 54 protons. Okay, so let's just summarize this slide. So this here is the periodic table which lists all of the elements, okay, and each type of element contains the same number of protons. If we were to look at an element under a very strong microscope, we would see that it's made up of lots of tiny particles that all look exactly the same. These smallest individual parts of the element are called atoms. In GCSE chemistry, we learnt that an atom is the smallest part of an element which can take part in any chemical reaction. If we look over and go back to our previous diagram of an atom, we can see that the atom is made up of 3 different types of subatomic particles. These are protons, neutrons, which are in the nucleus, and then electrons, which orbit around the nucleus in a cloud which is arranged into different shells. The chemical reactions involve electrons in the outer shells of the atom. Understanding the electron configuration of an element is important in understanding its chemical properties. So, to summarize this slide, we've seen that an element is made up of many atoms that all look exactly the same. An atom is the smallest part of any element, and that can take part in a reaction and remain unchanged. We've seen that the atom is made up of protons, neutrons, and electrons, with the protons and neutrons in the center of the atom, called the nucleus, and the electrons orbit around the outside in shells. And electron configuration affects the chemical properties of the atom. Okay, let's now look at isotopes. Here we have our diagram of the atom again, and this isotope is called carbon 12. Why is it called carbon 12? As we've already discussed, we've said that this atom contains 6 protons. Therefore, because it has 6 protons, it is carbon, but it also has 6 neutrons. So 6 protons plus 6 neutrons, 6 plus 6 is 12. So this atom has a mass number of 12. We can also write carbon 12 in this format here, 12C6. What we can see is that the top number, the 12, is the mass number. And we can also see that Z, the lower number, that's the proton number or the atomic number. Remember, the fact that there are 6 protons also tells us that this is the 6th element in the periodic table. And finally, the letter to the side, the X, this is the element symbol as given in the periodic table. Okay, so to summarize this slide, the atomic number is the number of protons, as we've said, and the mass number is the total number of protons and neutrons. Remember, in this atom, it was 6 protons and 6 neutrons. 6 plus 6 is 12. Let's now look at a more complicated example of isotopes. Here we have 2 isotopes of scandium, scandium 45 and 46. Let's focus on the number of neutrons in scandium 45 to begin with. Scandium 45 has a mass number of 45 and an atomic number of 21. This means it has 21 protons. The number of neutrons in this isotope of scandium 45 would be the mass number minus the atomic number, 45 minus 21, which is 24. So scandium 45 has 24 neutrons. If we compare this to scandium 46, that has a mass number of 46 and an atomic number of 21, we see that the number of neutrons in the scandium 46 isotope is 46 minus 21, which is 25. So scandium 46 has 25 neutrons. Notice that the mass number of scandium 46 is 1 more than scandium 45. Therefore, the number of neutrons in scandium 46 is 1 more than in scandium 45. You'll also notice that the number of protons in both scandium 45 and 46 are the same. This is because all scandium atoms have 21 protons. You'll also notice that the electrons in both scandium 45 and 46 are the same. And the electrons are the same, the number of electrons is the same as the number of protons in both cases. Since scandium 45 and 46 have the same number of electrons, they have the same electron configuration. This means that they have the same chemical properties, but because they have a different number of neutrons, they have different physical properties. Let's summarize the slide. The number of protons define which element it is. The number of neutrons is equal to the mass number minus the atomic number. Isotopes of the same element have the same number of protons but can have different numbers of neutrons. Finally, isotopes have the same chemical properties but different physical properties.